From the Autoline studios, here is your host, John McElroy.
Want to thank you all for joining us here on Autoline this week, where the discussion on today's show is going to be about the electrification of the automobile. And that's because we've got an expert here who probably knows more about this topic than just about anybody else in the world. And she is Ann Wright, the Group Vice President of Engineering and Product Development at Johnson Controls, better known as JCI. Awesome having you here, Ann.
Thanks, John.
Joining us today, too, are Jeff Bennett from the Wall Street Journal and David Welch from Bloomberg. And great having the both of you two here to help me
Thanks. Great to be here.
Question her about where is this electrification going? And I'll start out by saying this, Ann. The automotive industry absolutely needs electrified cars, if only to meet all the regulations for fuel economy and even CO2 emission reduction. And yet sales of these cars, especially in the U.S. right now, are going nowhere. How's the industry going to deal with it?
Well, I'll tell you, first of all, let's talk about how you define electrification, because electrification means you can take previous mechanical loads like steering and brakes, and you can electrify them. Better for fuel efficiency, better for overall vehicle efficiency, gets weighed out. You can talk about electrifying cars with motors and batteries and inverters for even better fuel economy. So I think there's a whole spectrum of what we're going to be talking about electrification. And I will just tell you that we've built models, we've had them independently validated, and where the regulations stand today in the U.S., you could meet those regulations without ever building a hybrid or electric vehicle.
Is that right? Is that because of how they've changed the law? It used to be you had to average out all the vehicles that you sold. These days, it's more about the footprint, the size of the car, and what they have to achieve within that footprint. Is that what's changed?
Well, that's a piece of it, but actually, if you take a look at the internal combustion engine, it just continues to get increasingly efficient. I serve on the board of Argonne National Lab, and the guys there believe that there's another 30% of efficiency gains to be had just in the internal combustion engine. So if you think about that, it just continues to push out things like hybrids and electric vehicles, because there's so much technology in gasoline, diesel engines that will drive fuel efficiency and get you to the regulations that are proposed for 2025. Footprint's a piece of it, clearly, but when you look at just pure efficiency of all the systems across the vehicle, light weighting, low rolling resistance tires, lubricants, I mean, the OEMs have tons of levers that they cooled EGR. All these things you can do without ever having to electrify the powertrain.
Well, and weight is a big piece of it, because every new car that comes out seems to be 300 or 400 pounds lighter than the one.
Finally, because in the last decade prior to this, they kept getting heavier and heavier.
And you don't need all aluminum to do it. I mean, you know, there's more aluminum going into the car, but you know, just steels and just really, it seems better manufacturing even in design. It's just helping cars get a lot lighter. But they're using smaller engines as a result, and it's saving money, and it's boosting efficiency.
Ann, though, at JCI, though, I thought what you were hoping for is more hybrids and more electrification of the powertrain, because you're making the batteries that could make this happen.
Well, you're right. I mean, we make 1 in 3 batteries that are in the world, but even if you have hybrid, you have to have a 12-volt battery, that beautiful lead-acid battery that, you know, turns the car, that cranks the engine and provides the lights. But when you look at, again, you know, if you approach this very rationally from an economic and what you have to achieve both in terms of fuel economy emissions and just fundamental performance in the vehicle, there is a ton of runway left in 12 volts. The vehicle electrical architectures are getting more efficient, so they're able to handle the increasing loads from accessories, things like, you know, I discussed mechanical to electrical loads, and just having a higher capacity, a battery that can do more cycling, like a start-stop battery, will drive up to 5% fuel economy, which to an OEM is a lot of fuel economy, without changing anything in the structures, without touching the powertrain, and just providing more capability for the engine to be able to pull down, provide the critical loads, and then pull up when the vehicle needs to continue to move.
You know, on that battery subject, Ann, you know, we see that Tesla and Ford and others are choosing battery makers, and I'm sure you've heard some of this too, but I mean, we still have not seen Johnson Controls batteries going into a major automaker in a big way, and I'm wondering, why is it that Johnson Controls still has not kind of clicked with somebody to become a major supplier of batteries? What's still the holdup there, do you think?
Well, first of all, we provide batteries to everybody in the world,
Right,
you know,
right.
the traditional lead acid and the start-stop batteries. If you take a look at the market, Jeff, in terms of hybrids and electric vehicles, it's still sorting itself out. And here's the issue, you know, and I'll answer it in two ways. One is as a 30-year veteran of this industry, and the second as a battery manufacturer. If you take a look at electric vehicles today, they work really well. I mean, we've proven, you know, through the Prius and all the other manufacturers, the hybrids work really well. The electric vehicles work well, but there's still compromises, and they cost too much. Mm-hmm. And the fact is, the OEMs know that they have to meet the regulations, but what they try to do is they're looking at their cost, and they're looking at billions and billions of dollars of legacy assets. Powertrains that cost $1 billion to develop. Body structures, not only just to stamp the parts, but in the assembly plants. And then the engineers that they have to pay to integrate and develop, and then the piece cost. And at the end of the day, whatever they do, the customer has to want to drive it, right? And so what we're finding is electric vehicles are going to be niche for a long time, for two reasons: cost, and the performance, to be quite honest. And there's
You mean range when you say
range,
performance.
right? And there's a lot of compromises. So we've made conscious choices about where we're playing, and we're playing very, very heavily, you know, in the start-stop market and in what I call the low voltage. And without getting too geeky, low voltage is anything below 60 volts. And the reason that's important is that's the threshold of electrocution. And so if you go over 60 volts, like a mild hybrid or a hybrid like a Prius, you have all kinds of safety redundancies. You have software, hardware, multi-point failure, you know, protection that you have to not only protect the occupants, but you have to protect everything around it. All of that overhead does not do anything for delivering fuel economy or performance to the vehicle. So if you can keep below 60 volts and get rid of the weight, the cost, the size, and focus on performance, so a 12 volt, which is a lead acid plus maybe a small lithium-ion battery, or a 48 volt, you can get, and particularly in the 48 volt, you can get the equivalent fuel economy that you get in today's mild hybrid for hundreds of dollars versus thousands, and a uniquely engineered platform.
So then what's the business case for the really strong hybrid stuff like a Fisker, like a Volt, or the EVs like the Leaf and even a Tesla? None of these cars make any money. They've had to discount them again and again to get consumers to buy them. So, I mean, when I look at that and then I listen to what you're saying, it's the picture I'm coming up with is, you know, very mild hybridization and, you know, some electric boost is much better solution than trying to go full bore, because, yeah, these cars are cool. People love them. I love them. But they're just not selling in big numbers. They're not a good business proposition for anybody. What makes them a good business proposition at some point?
Well, I think it's going to be a tough business proposition, because every one of those, and let's talk about it like in three buckets. You have your traditional, you know, 12 volt, you have your lower voltage, and then you have high voltage. And within there you have two kinds of scenarios. You have hybrids, and then you have all EVs. But in the hybrids and EVs, there's so much cost outside of just the electrification of the powertrain. You literally have to build the vehicle around all of that. And so I go back to powertrain structures, and it is a very difficult business proposition. And that's why you see less than 5% of penetration. And from a pure regulatory standpoint, and I'm going to put California aside, who is trying to regulate themselves, but if you look on a national, you wouldn't do it from a business standpoint. They're important because it continues to be disruptive, and it makes us better at, you know, product development and getting features and value and performance that's important to the customer. But from a purely economic and regulatory, you wouldn't do it. And I think in the case of mild and full hybrids, I think in fact when you look at how the 48 volt is going to mature, it could in fact make things like hybrids extinct. And the reason, and that's probably a big statement, but if you think about it purely from a performance standpoint, if you can get near equivalent performance without all of the high voltage isolation, all that packaging, all the things that you have to do for hundreds of dollars, and oh, by the way, you don't have to tear up your powertrain in your vehicle, I think that's going to be a disruptor for us.
And that's 48 volt with lead acid batteries?
Well, it would be a lead acid for the cranking functions, and then a small lithium-ion battery up to 48 volts to handle things. They'd handle your high power accessories. So if you electric AC,
power steering,
your brakes, and then provide all that regen so that you can capture it and then use it.
Does it help with boost as well?
It absolutely can and help.
almost
electric
like-
turbocharger.
Yeah, that's exactly right.
turbo.
Yeah, and in fact, talking about turbos, John, going back in history, back into the 80s and 90s, turbos were horrible. I mean, you had the legs, they about died. Would you have ever thought today that turbos would have become ubiquitous? In terms of disruptive technology, I can't think of anything in the last 20 years that is this disruptive, and everything has a turbo. So
And they drive beautifully.
they drive
today.
beautifully. I mean, and so this is my point, is that electrification is going to have lots of definitions and ways of looking at it. But things like, 1 turbo was good, 2's better, 3 might be great, and 4, right? But I mean, that is truly disruptive. And what has it done? We now have an and proposition. I can remember, 15 years ago where it was fuel economy or performance, fuel economy or weight. Yeah. And now it's fuel economy, performance, features, function. It's and. I mean, it's awesome because all of this technology is not requiring us to make those compromises anymore.
Let's go back to stop-start, which, in case any of the audience doesn't know, it's when you come to a red light or a stop sign, your engine will shut off, and that little bit actually does cut down on emissions and saves fuel. But a lot of people don't like that. Now, I don't know if it's because they've driven early versions of stop-start. When the thing would start again, it could send a shudder through the car. The new systems don't do that anymore. But there is a lot of consumer unease with stop-start.
Well, I'll tell you, when you look in Europe, 65% of the new vehicle build is start-stop. And in the early days, start-stop in Europe was 2007, so we've got about 8 years of experience of it. There was pushback because it was rough. But it's like any other technology development. But if you are in Europe, you won't be in a car that doesn't have start-stop. And they aren't disabling it, and the customers love it. 2020, it'll be 85% of the market. In the U.S., and I think the execution that Ford did of Fusion is beautiful.
It is.
It is absolutely flawless.
But I've driven cars like BMW in particular, where right where the ignition switch is to start the engine, there's another switch where you can turn off stop-start because people were complaining about it so much.
Well,
I think that one of the complaints is I was just driving a Malibu with this over the weekend, and it was like 92 degrees. When you stop and the engine kicks off, the air conditioner kicks down significantly. So I found myself letting my foot off on the brake just a little bit so that it would kick back in, but I'm still waiting at the red light so I can get the air flowing again. Because it was like 92 and humid here all weekend. And that's I think where you get some of the issue. This kind of gets down into the weeds. I think most people probably don't really notice or don't care, but
I don't know. I've talked to chauffeurs in Europe in particular who hate it. And these are drivers who drive, 24/7. That's what they do.
but I think, so that may clearly.
But this was a few years ago that I talked to chauffeurs, and I know the systems have gotten better.
They really are. I mean, and they're ubiquitous. I mean, they're everywhere. You can't go to Europe and not have it, but even in the U.S., by 2020, 40% will have it. And the reason, again, is one, you're going to have more capability. Not only just, and so this is an important point, David, that you bring up. You don't even have to make it a start-stop function. You could actually use that capability in the battery in the system to do alternator management. And when you do that, you just make all the other systems more efficient, so you get the same amount of fuel economy.
Wait, explain that, because I'm not following. What do you mean alternator management?
So if you use I'll use a start-stop battery, and instead of making the engine pull down when you don't need it to propel you, but instead use the power that is available for what we call alternator management, which the alternator is helping to manage all the electrical loads. And so if you're making sure that the right power is going to the right module for the right function at the right time, you can get equivalent fuel economy without having to use the start-stop function. So OEMs are evaluating both kinds of strategies. The start-stop has gotten very smooth, and 5%, which, over a year in a typical car, it's $100, isn't a lot. But in terms of real fuel consumption, if you think about getting the fleet that we're talking about, that's real significant fossil fuel reduction. And that's what we're talking about, is real reduction. And if you use the alternator management and you don't use a pull-down strategy where you shut the engine off, you'll get equivalent. So there's and that's what I think is so amazing about what's going on in the auto industry today, is there's so many new technologies and levers that aren't exotic. And so you talked about in your Malibu how you started getting warm air coming out of your AC. I don't know if you saw what Denso is doing. Denso is actually working on some technology to run cool air over the condenser, so it will continue to provide that cool air and comfort while the engine's pulled down without doing any additional hardware into the vehicle. I mean, there's really some cool stuff.
It actually kept the cold air going. It just kicked it down significantly. But so talk again about the 48 volt systems. What's your outlook on that? How prevalent does that become, say, by 2020? Is that or even 2025? Is that the dominant system because of the tough economics of the rest of these, the more high tech stuff that we're seeing out there in terms of electrification?
Well, first, our view is that it'll come out in Europe, where in 2021 they have to get to their 90 grams per kilometer emissions. And so that is where we see it coming out. So you'll start seeing it hit the market in the 2019-2020 timeframe. It certainly, if the regulations as promulgated right now for 2025 in the U.S., you would start seeing it post 2021. And in China, which likely will follow the European Union, you'll see it in the same time frame. So we really see it starting to hit the market in that 2020. And I mean, it's pretty smart technology, and it can be packaged anywhere. John, I think you saw the vehicles that we had at Lawrence Tech. You can package it under the hood if you've got some packaging space, and that's another thing, is we're trying to make it robust to the environment, because it's pretty hot underneath the hood of a car. But we're trying to do it in a way that is not disruptive to any of the other vehicle systems inside of the car.
So it's just sort of a bolt-on technology?
Yeah, that you should be able to drop it in, and whether it's in the wheel well or if it's under the hood of the car.
And it's ready right now, right?
I'm sorry?
It's ready right now.
No, it's still in development, but it will be ready. By 2018, the technology will be ready to hit the market.
Marianne, there's been so much improvement in nickel metal hydride, but especially lithium-ion batteries. What about the lead-acid battery? I mean, that thing has been the same since 100 years ago.
Well, it hasn't actually been the same. I mean, we continue. The thing about lead-acid that you love is it's fine in the heat and it's fine in the cold. And that's what's so tough to break away from this technology, is it's so robust in an automotive environment. You will reach a point, just because of physics, where charge acceptance, so in our world, charge acceptance is the holy grail. So the more charge you can get inside the battery, the more functionality you can provide. Now, of course, you have to have things like alternators that can manage it and everything. So we're working really, really hard on extending that runway, because it's works so well and is proven to get as much charge acceptance as we can. And so things like our AGM and EFB start-stop, which you two have certainly been exposed to, just help you get up to 4 times more cycling than you get in lead acid. But there will come a point where lead acid will hit a ceiling, and that's where things like nickel metal hydride, lithium-ion, and there's some other things on the horizon that will help you to get the charge acceptance. Because the more charge acceptance that we can get and put it out into the vehicle function, that's what's going to deliver the performance.
So will JCI make more than lead-acid batteries in the future?
Well, we already do.
Oh, you do? Okay, I wasn't aware of that.
Yes, absolutely. So we make that beautiful black box in lead acid, but we went into production in 2009 with Mercedes with lithium-ion. We built our plant over in Holland, Michigan, and that's where we provide our batteries out of for Mercedes and for some other customers on EV, and they're primarily in fleets. And so on the EV side, if I'm going to give a positive part on the EV, if I could. In fleets, it makes more sense where you have prescribed routes, you have central fueling stations, and you know what the usage cycle. And that's where we see, in electric vehicles that it has made some sense. It's still a very tough economic situation because everything has to be uniquely engineered. So if you think about these programs, if you have to engineer a car every time for a new electric vehicle, I mean, that's, back to your original point, David, this is why the business case is so tough. You have to pay the engineers, you have to tool everything, you have to work with your suppliers, and it's expensive.
What do you think overall, though? I mean, it seems like we've kind of reached a point where the interest in hybrids and electrics have kind of stalled out almost. I mean, the numbers suggest that from consumers. They're just not buying them, or, if you focus, maybe California buyers will buy them. But overall, there just seems to be kind of a lack of interest or lackluster products that are even out there. I mean, what do you think that needs to come along to kind of kick us back into this mind frame? Is it like $5 gas, or is there something else that needs to happen that would kind of, I don't know, juice that segment back up a little bit?
Well, certainly fuel prices will drive. I mean, we saw it. But my view, our view, frankly, is there's always going to be a segment of the population that does it, and they do it because it's very important to them. They want to drive a vehicle that they know is leaving the minimum footprint that it can, and it's very important. So there will always be that market, but it's right now about 5%, and we see that through the 2025 kind of time frame.
I'd say it's more like 3%. And amazingly, even with our cheap gasoline, the United States consumers buy more hybrids, plug-ins, and electrics than any other market in the world.
Right. You're right. And so whether it's 3 or 5%, it's still going to be a niche market. But it's important, again, because it is that driver that helps us, make the technology advancements. I'll tell you, if you look at hybrids today, we should be very thankful to them because it's improved all the other vehicle systems. Think about electric AC and how much more efficient. We got tons of weight out of the car for doing that. Battery technology certainly has improved. Engine technology. I remember when I was doing the Escape Hybrid, we went from an Otto to an Atkinson cycle just so that we could get the peak efficiency. Now they're blending the cycles. And this goes back to my original point, is that all these engineers are saying, wait a minute, there's still a lot of runway in the gas engine. And we are absolutely not done with gasoline or diesel. And in fact, where diesel hybrids never made sense, now we're seeing, hey, wait, the diesel paired with the right hybrid system, it won't necessarily need the next level of after treatment, which was very, very expensive. And again, not a big return in terms of what the customer values in terms of function. And so now you're starting to see kind of blends of some electrification, not all hybrid, but some blends of electrification with our traditional technologies that are just going to continue to push out higher levels of adoption.
This is amazing what you're saying, of that the internal combustion engine still has a lot more efficiency to be wrung out of it. Can you give us some examples of what that might entail?
Sure. Look at, there's still the work that's going on in direct injection so that you get precisely the amount of fuel that you need. I mean, the work that is going on in terms of injection technology, cylinder deactivation, cooled EGR, smaller displacement paired with turbos. I mean, turbos and going to electric turbos. I mean, I think that's the next breakthrough as we look at those kinds of technologies. Lubricants. Whoever thought lubricants were fun, right? And so all the work that is going on to reduce the friction. So there's just so much going on inside of just the fundamental engine that is going to continue to propel the vehicle market for a long time.
With the amount of spin-offs we've seen, your company throwing off a couple of units here and there to kind of focus that, I mean, now that once those sales are done and those spin-offs are complete, do you think Johnson Controls becomes a different kind of company within that auto space, within that technology and battery, where we see you, I don't know, just putting much more dollars in those segments than you have ever before to kind of I don't know, push the envelope ahead on some of these industries?
Yeah, so clearly the Power Solutions, our battery division, is a growth platform for the company. I mean, we've been very explicit that we see this is a huge growth engine for the company. And we're looking at not only expansion in automotive technology, but energy storage spaces way beyond. And if you think about our portfolio with our buildings business and the need to have uninterrupted power, grid stabilization, we just see a lot of opportunity to extend our experience and our expertise to those kinds of applications. And in fact, we've stood up a new business group inside of the corporation to explore that.
Is this sort of what Tesla and Elon Musk are doing with the Gigafactory? They see storage for buildings, as, especially for green storage from solar and wind, is part of that. Is that something JCI is going to look at?
Yeah, I mean, so, Elon should get a ton of credit. I mean, and what Tesla has been able to do in terms of disruption. And anytime, you see the envelope getting pushed, it just makes all of us better. And so for him, he's seeing, the electric vehicle business model is a tough one. But he's very committed to it for a number of reasons, and he also sees that the battery technology has a lot of application. And the same kind of technology that does well in a car can do well in other applications. And that's very much the way we see it as well, is that the batteries that power your cars have a lot of adjacencies in which we can leverage in the marketplace.
And with that, I'm afraid we're going to have to wrap this up. We're down to the end of our time. I told you it would go fast.
Wow.
Mary Ann, you've been so fascinating. I'm going to have to go back and watch the show again myself and take some notes on what you were talking about. Thanks so much for coming on Autoline this week. Been terrific having you. And Jeff Bennett from the Wall Street Journal, David Welch from Bloomberg, great having the two of you here too.
Thanks, John.
And I want to
you.
thank all of you for having tuned in.